I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, Real-Time Business Intelligence with SQL Server 2005 Analysis Services. Now it is my pleasure to introduce today's presenter, Sean Travers, who's an IT Pro Evangelist with Microsoft. Sean, you now have the floor.
Thank you, Heather. Yeah, this is going to be a great session. Kind of a follow-up to understanding analysis services in SQL Server 2005, the introduction session we did on Monday. It should be a great session, so I'm going to go ahead and get underway. Hopefully you have some understanding of analysis services, and you've used some of these different concepts before, because we're not going to go through and explain in detail the introduction side. We're going to go straight into understanding how we can get more of a real-time business intelligence scenario where we can pull the data and view it in real time without directly accessing the database, which is kind of a nice plus. So as we go through today's session, you'll hear different acronyms and terminology, and I'll explain them to a certain extent, but you'll need to have an understanding of the key concepts, like OLAP and analysis services and dimensions, as well as some of the different storage methods like MOLAP, right? And we'll talk about some of these things, and ROLAP stores, right? So some of these might be new for you. We talked a little bit about like the Unified Dimensional Model, or UDM, which is a new term for SQL Server 2005 Analysis Services in the prior webcast. But you should be in good shape to follow through if you understand most of this terminology. And again, I'll explain much of it that you have maybe not seen before. All right, so first off, let's talk about what are some of the challenges and why actually we might need real-time business intelligence. And so it's easy to find any number of reasons why a company might benefit from real-time BI. Like, for example, say we're going to use this example today, like you're running a call center, right? And you may need to know about the volume of calls in the morning in order to plan properly for your afternoon call volume, right? Maybe to maximize the efficiency of your call center, you might make changes from the morning to the afternoon just to adjust to those the changing demand of call volume. So online transaction processing, which is OLTP, these kind of systems, they're real good at delivering this kind of information. And the information alone is useful, but even more useful is being able to see it in a historical context. So maybe call volumes are particularly high in the mornings historically, while afternoons are at a low volume. Or, you may find that historically when call volumes are low in the morning, they might be high in the afternoon. So trying to combine this up-to-date data from an OLTP database with historical data from an enterprise data warehouse can be, problematic, to say the least, right? Frequently we'll build custom clients and applications. We might have difficulties in creating correct business rules to make sure that we're comparing the right data in the right way to make these business decisions, right? So really, real-time BI provides this single version of the truth, and we kind of introduced discussions around that earlier on the previous webcast. But for those of you who didn't see that, essentially real-time BI and this single version of the truth contains up-to-date information from multiple heterogeneous databases, right? So it also can include that historical context that we may need to help us make the best decisions based upon whatever information is available. And so rather than having to go to multiple places or building complex custom solutions, we can, provide this solution through SQL Server 2005 Analysis Services. And that's one of the big changes with this version of SQL, is being able to give this much more real-time experience. And I should point out, it's not 100% real-time, right? And that's something that's almost impossible to do today with any solution out there because of all the challenges around that. And I'll talk more about the challenges in just a minute. But basically what we're talking about is real-time enough, right? Close enough to real-time to give us that ability to make those decisions based upon meaningful data, right? So rather than running it daily, which clearly wouldn't make sense in our scenario with our call center, we need to be able to see this information maybe every few minutes, right? Updated every few minutes. And to do that in the past has been real challenging. So it's not quite up to the second data, but it's definitely, you can set it up to where it's, up to the minute. So to provide this real-time information, we may start out by connecting customers and orders directly to our OLTP database and generating our information directly from a source system, right? But we may also do this using a replicated database in order to keep the source database more secure. So we might have our second replicated database, and that might be where we pull the information from. But the problem with this is queries against the OLTP systems take a longer time to run as the data grows larger. So as the volume of data that we have gets larger and larger over time, these queries take longer and longer to run. And so this solution becomes, this simple scenario of just, pulling all this information becomes less and less viable to pull it directly from the source system. So reporting from the source database is also difficult because, we may have multiple source systems, as I mentioned, and the data from all of these source systems needs to be combined, right, and manipulated in a SQL Server integration services, right, placing it into a data warehouse so we can do our reporting. And the other reason it's challenging is in the data warehouse, we may need to use analysis services to cache that warehouse data and really pre-calculate aggregate values, right, to help provide that summary data for business reports. And so populating the caches and performing calculations on that data can really take a long time. And so we lose out on that ability to have that kind of real-time experience and real-time report. So data latency can be worse, if the data is moved. So give you an example. If it's moved from a data warehouse to a staging cube, which is what we frequently would do, right? And they'll go through a validation process, before it's moved again into a production cube. And so on the end user side, there's even more delay, right? So besides the fact that we're moving it around from staging to production on the server side, on the end user side, when the data is moved into the production cube, the users don't even know about it until they rerun the reports or their applications to get the data. And they're finally able to make decisions based on that information. So real-time BI, as you can see, is difficult for all these reasons because end users move farther away from their source data as the business grows. So the data has to be pulled from multiple sources, put into the data warehouse, validated, moved from staging to production. User has to pull the data. All these reasons really create some real complex challenges around BI. So let's talk a little bit more about some of the barriers to real time, right? Because that's just kind of the tip of the iceberg. So one of the things we should look at is why we're creating a separate store, right? The data warehouse. And so why do we do that? Why do we create the data warehouse? Well, many of the features, right, in SQL Server 2005 analysis services have been designed to deal with, arbitrary, complex schema in an OLTP database. So, we may wonder whether this means we can do away with the data warehouse because of the fact that, SQL Server 2005 analysis services has been improved to really deal with this arbitrary, complex kind of OLTP system. So we do still need data warehouses, and there are a number of reasons why. First off, there's the need to present a historical view of the data, as we talked about in many cases, right? So the best place to maintain full historical data is in a data warehouse. Also, there's a need to coordinate with different business processes and across systems. So it may be meaningless or incorrect to compare information drawn from different sources on the fly without coordinating all that information with some business processes to ensure the data is somewhat meaningful. So just being able to, compare the data doesn't necessarily mean it's a meaningful result that we get out. So a data warehouse helps out here as well because it's the best place to do that comparison and to coordinate that information with the business processes. So we also need to manage the quality of the data. So we might be running expensive, time-consuming transformations to cleanse and bind the data, and it's really not feasible to do those on the fly, like in an OLTP system. So a standard OLTP setup, doing this stuff on the fly really doesn't provide for the time that we need to get the real-time data out. So we need to do the transformations and load the data warehouse with these results. So the sort of problems we've talked about here are not really able to be solved by applying just new technology to an OLTP system. So we still need the data warehouse. But when you look at the new features and functionality in SQL Server 2005 Analysis Services, there are some that can eliminate some of the barriers to real-time BI, and we find that we actually can use analysis services to overcome several previous barriers to real-time BI. So now we're looking at kind of, what are we doing to improve upon this? So first, in some cases, we may be introducing a data warehouse solely to integrate data from multiple systems. So here, analysis services offers an alternate, called heterogeneous query processing, or HQP. So when we introduce this in SQL 2005, this HQP, we can now pull information directly from various sources, including SQL, Oracle, Teradata, DB2, as well as others, right? And so when we have the problem, of data consistency, there is a problem of trying to perform analysis on data that's continually changing. It's difficult to get a coherent picture of what's happening, from an analytical perspective. So when the source data is constantly changing, getting a real, coherent, true picture of what's happening is much more challenging. So let's give you an example of this. So let's say if we go to read a product table and then we read the sales table. While we're reading the sales table, maybe a new product could be added, along with a sales order for that product, perhaps. And so in that case, we could end up with reports that show sales orders for products that don't exist, at least from our perspective, because they were added to the OLTP database after we read the product table. So SQL Server 2005 helps address this problem with an isolation level you may have heard of, probably have, if you even went to the launch. I know we talked about it a lot there. It's called snapshot isolation. And so we'll look at this in more detail in a little bit later in this webcast. So normally we maintain a separate cache of data. First we're just going to talk about some of the barriers, right, to real-time intelligence in a little bit more detail, and then it'll really help us to understand how we can overcome these as we talk through our solution today. So by maintaining this kind of separate cache of data for performing the analytics, that creates additional challenges. So we need to be able to protect our OLTP systems from performance problems. And these problems are typically caused by intensive, excessive querying, right? So in SQL Server 2005 Analysis Services, we address these problems with proactive caching, and we talked about this a little bit earlier in the prior webcast. We'll talk about that more shortly as well, because proactive caching is something we want to spend more time on today, because it really deals more with the real-time aspects of analytics. We also talk. We also have new to analysis services. We have this data push concept, where we are able to push the data straight into the analysis services from the integration services without having to first place the data into an intermediate store. So you can see that immediately cuts down on time. So by having this proactive caching where we push the data into place and not having to have this kind of intermediate store between integration and analysis, we do have a significant time improvement. So when it comes to this problem, right, of knowing when the analysis cube is up to date, we've also addressed that with SQL Server 2005 through notification services. So it's possible really to define a threshold value of an MDX query so that users are notified when that threshold value is passed. So for example, we may ask for an email to be sent to our call system manager whenever the average wait time for callers is more than 5 minutes. All right, so the notification services helps to address this problem of knowing when the analysis cube is actually current. And then I guess finally, it's really been difficult in the past to link back to the original source system, especially in those cases where we really need the absolute latest, most up-to-date information. So analysis services in 2005 can now use actions to link back to the source database to get the latest data for making our decisions. So SQL Server 2005 analysis services can really help us use our source databases directly. And that's kind of the fundamental, the fundamental shift here. So with the new version of analysis services, you can see our diagram looks a little bit different now because we've taken away some of the steps that normally the staging and all the intermediate stores that we had before. We now have the ability, in some cases I should say, to pull data straight into a cube, right, or to push it into a cube, I should say, to stick with our terminology, without first, writing it to a data warehouse. So in this situation, rather than loading data from the data warehouse into an intermediate cube, just to have analysis services read it from the intermediate cube, perform the analytics, and then push it out to the production cube, we load the data directly into the cube. So we can do this using integration services to transform the data as we need it, and then push it directly into the production queue. In addition, since all communication with analysis services is done with web services, you could also just send an XML message to analysis services, which contains the updated data. So the ability to do this avoids the need for a separate store in some cases, although you may still need to use a data warehouse to address some of the barriers that really don't have available solutions, like, as we discussed earlier. So what's interesting about this is both fact and dimension tables can be pushed directly into the production analysis queue. So let's actually, kind of see how this works. We'll take a quick look at a demonstration here. We're going to start out just seeing how to push data and load it directly from SQL integration services into UDM. All right, so just to be clear, we're loading directly into UDM from SQL Server integration services. So I'll start out here on my SQL Server, and we'll open up our SQL Server Business Intelligence via Visual Studio, and we'll just take a look at what we have currently inside of the cube. So I'm going to open an existing solution. You can see I already have, and this again is one of the solutions that ships kind of with the sample database, right? And so I've made a few modifications to it just to add some additional data and make this possible. But we're just going to look at an analysis cube that's designed to normally use MOLAP storage. So whenever the MOLAP cache, actually before we get to that, let's just take a look at the cube that we have currently, right? So we'll take a look at one of the new abilities of analysis services, and we'll take a look at the ability to push data directly into the UDM cube. And so you can see I have my AdventureWorks data push cube here. So I'll just open this up. And then we'll kind of browse it and see what's inside. And what we'll do is, this cube has already been deployed and processed, by the way, on my server. So we can browse it and see some of the data. All I did was take one of the default cubes, deploy it, process it, and then add a little bit of additional data for our purposes today. But generally, this is just essentially a sample cube. It ships with the sample database in SQL 2005. And so if I click on the Browser tab up here, we're going to show you how integration services can push data directly into a cube. But we'll need to look at some of the data first. So first, we're just going to look at the order quantity measure from the fact internet sales table. I'm kind of waiting for this to come up too, so don't worry, you're not behind. But this will tell us the total number of products that have been ordered over the internet. And so I've got my cube here. Let me see if I can make this a little bit easier for you to see. And by the way, if you need to, F5 toggles you in and out of full screen if you need to see it a little bit bigger. But if I just expand out my measures here, and you'd see I have my internet sales measure, and I'm just going to go ahead and drag order quantity over into the totals and details field. You can see I've got a 60,000 plus orders. But I need to break that down a little bit more. So I'm just going to break it down and look at it by, say, product, right, and product category. So I'll expand out my product. I'll grab product category, and I'll just drag this into the row field. And then I'll drag maybe color over. We'll expand out product category by color. You can see I've got blue, black, multicolored clothing. But I also need the product name, right? So I can drill into the blue colored clothing and see I've got some classic vests that I've sold through AdventureWorks here over the internet. And you can see I've got a large, medium, and small vest. So in our scenario, and this is where it starts to come together, I think, for you, is all we're doing here is we're going to directly push in new size vests. So we're going to push in an extra large and an extra small vest. And clearly we want to do this in the right order. We want to push in the products first before we push in any orders that might have occurred against those products. And so doing it in the right order makes a lot of sense. And that order, I think, makes a lot of sense. And then we'll just take a look. You can see the changes that occur. So let me go ahead and open up my SSIS packages, right, for integration services. I've got one called Add New Products and Orders. And so this IS package really just consists, this is an integration services package, and it really just has two tasks there, right? The first gets any new products from the relational database and adds them directly to the analysis cube. And the second task of this IS package gets the new orders and adds them to the cube, as I just mentioned. So we're doing it in that order. And really, the tasks need to be run this way because we don't want to add orders to the cube before the corresponding products exist. Kind of like we talked about when I was walking through the slide. I'm just kind of waiting for it to come up. Things are running a little slower than I'd like. Well, there they are. So I've got in my control flow, I've got Add New Products followed by Add New Orders. Real simple, just like we talked about. And if I kind of double-click here on Add New Products, you can go to the data flow for Add New Products to see, what the data flow tasks are. And essentially data flow task is just a new type of task in SQL Server 2005. It allows us to read data from one or more sources, perform those transformations on the data, and then write the data to one or more destinations. I should repeat that just so everybody's clear, because I know data flow tasks are new for some of you, right? It's a new kind of task, allows us to read data from one or more sources, perform those transformations, right? So we don't need that intermediate store, and then write the data to one or more destinations. So if I double-click here on dimension processing, the dimension processing destination is a new data destination in SQL Server 2005. And we can look at the details here to see how the data gets added to the product dimension. So in the dimension processing destination, we've selected the product dimension to receive the output from the Get New Products task. Right? And so we've also specified that only incremental updates should be performed on the product dimension. So with this option specified, the IS package will add only the new additions to the dimension instead of reloading all the products, right, which would take a long time. And so this helps us save time, helps us save resources in kind of reprocessing this dimension. So again, if you're not too familiar with cubes and things, it's probably going to be a little bit lost on you. But the basics here are pretty simple. A cube has many dimensions, right? Different aspects that we can look at and peer into the data. And so all I'm doing here is saying, well, just add a couple of new dimensions, right, to the product. I'm sorry, add a couple of new items to the product dimension, right? So we're adding extra large and extra small. If you look at the mappings, you can kind of see the available input columns. Make that a little bigger so you can see everything there, and then the available destination. Right? So product key goes to product name, product name. You can see how everything maps here. Category name goes to product category, and so on. All right, so we'll cancel out of this. Right? We just wanted to see how everything was working, and how you can see these things aren't that complex once you look at the dimension processing side. And if I check out my control flow tab again, I could see, maybe double click on add new orders. You can see how the flow works when adding new orders. Same kind of a concept here, but this time I'm getting new orders, and then I'm running the partition processing. So if I open up the partition processing side, again, we're not making any changes here. We're just examining it for the purposes of understanding, right? You can see that we're connecting into the local project. You can see, again, we're processing incrementally, right? And as we saw, the same thing we saw with the dimension processing destination. We map our input columns that we're receiving, right, to the columns in the internet sales partition. So these mappings also have to be one-to-one. So everything here is kind of one-to-one. There's no multi-mappings that go on. All right? So pretty simple. Again, we're doing incremental as well, so I'll just cancel out of that. If I click back into my control flow tab, I can double-click add new products again because I want to run that first. And I'll just click start debugging to kind of walk through this. This takes just a minute, but what we're going to do here, and I've got actually a break set in here after get new products before we do the dimension processing. But all we're doing is, getting new products, XL and extra small for the vests that we want to add into the product database, and actually we're pushing them directly into the AdventureWorks data queue. You can see the deployment has started. We're just kind of waiting for things to take effect. So we're running the package, and since we've got our data viewers enabled, I could see those data viewers. They come up and show me what data is being added. That'll pretty much take care of our understanding of this process. This will show us exactly what data is being manipulated during the execution of this IS package. First, I got a little visualizer there that'll go away, and then we'll see our data viewers come up. So the package is going to execute, but it's going to stop while we take a look at the data here. You can see the execute phase is beginning, and we kind of have a little pause here. And if I open up this data viewer, you can see there's my new vest. The classic vest extra large and the classic vest extra small. Colors blue, adding it to the clothing category and the vest. And if I look at my cube, and I kind of do a reconnect, and get rid of some of this extra stuff. We don't need the viewers so much. You can see the data will come in to the classic vest category. Just taking a little longer. So, all right. Let's jump back out. And we'll take a look at what we've done so far. And you can see all we've done so far is kind of, give me just a second here. Waiting for everything to catch up with me. All we kind of did there was we saw how the how we could use data push to load the data directly from SQL Server integration services. So we use that, SSIS package, and all we did was essentially add new tasks by adding first products and then adding the orders related to that product. So now that we've kind of talked about the challenges of providing real-time BI, and we've actually seen how to use integration services to push data directly into a cube, well, now we need to talk more about delivering real-time BI, right? So we've kind of gone through the server end side, but what about the delivery side? And we've talked through the challenges. Let's see more about the solution. So we can use trickle feeds, all right, to keep the cube up to date. And that's kind of what we walked through, the kind of trickle feeds that get data directly into our UDM. And that's just what we just did. So instead of running packages weekly, daily, or hourly now, we can run packages every 15 minutes or so. Integration services isn't really designed to run packages continuously, like every few seconds, but we can certainly run packages every few minutes, like every 15 minutes. And that is pretty darn near real time. You can actually run it faster than that even. It just depends upon what your needs are and what your hardware will support. But in this case, what we did is we had, and you can see our diagram now again, integration services receives data from the OLTP databases every few minutes. It transforms the data and loads it directly into the production cube. And that's just what we did, right, in our demonstration. And this keeps the cube up to date with just a few minutes of latency. So in some cases, the integration services packages, however, may be doing no more than combining data from multiple sources. And so in this case, when we're just kind of combining data from multiple sources, we're actually able to simplify the architecture even further and build the cube and source it directly from one or more relational databases. So this architecture requires that at least one of the underlying sources be SQL Server. So because we are using the distributed query processing capabilities of SQL Server, we need to have at least one of the underlying sources being SQL. It can't just be DB2 and Oracle, for example. But it could be SQL and Oracle. And so that's kind of one of the gotchas, I guess you'd say, from this architecture. But on the plus side, even though you have to use SQL Server for this architecture, none of the actual data we're loading into the UDM has to reside in a SQL Server source database. So your source databases could be, DB2, Teradata, and Oracle, and as long as you're using SQL Server in the architecture somewhere, you can still perform, that building of the cube and sourcing it directly from those relational databases. So, for example, let's say we could be loading data into a UDM, right, where the source data all comes from Oracle and DB2, but all you need to do there is use SQL Server just to do the distributed query and the join. So SQL is there just to do that distributed query and the join. So this architecture is not always applicable. So we just need to look closely at what sort of data we have and what transformations you need to make before deciding to use this particular variant of reporting from the source database. So as we mentioned earlier, one of the barriers to real-time BI is the problem of continuously changing data. And in OLTP systems, the data is continuously being updated and added. So we need to have a way to ensure data consistency whenever we're providing real-time BI. So when we're trying to process the cube and set up the analysis services caches, while the source data is changing, we can have a problem, right? So how can we get to a point where we have good data consistency? So in SQL 2005, this problem is solved. It's called, by that new isolation level we mentioned earlier, the snapshot isolation. So when you define a data source within analysis services, you can specify that all the data for the cube have an isolation level of snapshot isolation. So all the data for the cube has an isolation level of snapshot isolation. So that way, when analysis services starts to read the data into the cube, all the data that's read will be as it was at the time the analysis services started the transaction. So therefore, we have a complete snapshot of the database taken when analysis services starts and when that transaction, and then pulls that data over. So the analysis services starts the transaction, pulls the data over just prior to that happening. At the instant that happens, we get that complete snapshot. And this allows us to perform analytics on the OLTP source, even when the source data is continuously changing, and still get a consistent view of the data. Does that make sense? So if we weren't able to get a snapshot in time, we would have a rolling progression of data coming in, and we would not have absolute consistency. And we would be concerned about, at the very least, inaccurate data, but potentially even very disruptive problems for the whole analysis. So when the source data is taken a snapshot of, we can then pull that data during that time. So with proactive caching, analysis services is essentially keeping its own separate copy of the source data, as well as the pre-computed aggregate data. So as with any cache, this brings up several questions, right? Such as whether or not the source data has changed, when to refresh the data, how to answer the queries during the process of the refresh. So proactive caching really allows us to create a set of policies defining how the cache will be maintained. So proactive caching allows us to deliver OLAP query performance, which is better than query performance against a large source database, but also allows us to get real-time access to the source data as we need it in order to deliver that real-time BI. The one main point of proactive caching is that the policies, they're going to allow us to develop the data without having to explicitly process the cube, as you normally do with a traditional OLAP kind of load and run scenario. So there are many different scenarios where proactive caching can really help to deliver this real-time BI. For example, let's say we have a client issuing MDX queries to the UDM, right? And the UDM is answering the queries from the MOLAP cache that's being maintained. So at the moment, there is no communication between analysis services and the OLTP database because the MOLAP cache is up to date. Later, an update happens to the relational database. An event comes through to the UDM announcing that the data in the relational database has changed. Sometime after this, depending upon the policy configuration, two things will occur. First, either we'll drop the old MOLAP cache because it's exceeded acceptable latency, and then, I guess, also, the second thing that occurs is when an MDX query comes in, the UDM will go to the relational database to get the most up-to-date information. All the time this is happening, we'll start creating a new MOLAP cache to bring the cube up to date. So after the cache is rebuilt, a new MDX query from the client will now result in the information being returned from the MOLAP cache, because now that new MOLAP cache is up to date. So real simple, update happens to relational database. The event, I'm just restating this so everybody kind of is clear. The event comes through to the UDM saying the relational database has changed, and then two things occur. We drop the old MOLAP cache, and then we go to the relational database directly. And In the meantime, we're updating the MOLAP cache so that the later query can go there to get its information. So this enables, as you can see, a kind of a slight variance on the reporting from the source scenarios that we saw earlier. In this scenario, the UDM is getting data from multiple sources, and the proactive cache is refreshed according to the policies we defined in the cube. So, additionally, no external process has to kind of manage the rebuild of the cache. So, in this next demonstration, we'll kind of take a look at how proactive caching really works. So, we'll show how a cube that's set up to use MOLAP cache provides kind of answers to the queries. And then we'll create latency with the data and see how the cube reverts to ROLAP, right, the relational online analytical processing, according to the policies we've defined. All right, so we'll start out here, again, on my SQL Server. We'll just open up a project that we have that kind of goes through this. I'm going to stop my debugging there and start over with the new project. So we're going to look at how, at an analysis cube, it's designed to normally use MOLAP, storage. So whenever MOLAP cache is out of date, the cube will resort to ROLAP. So we're going to kind of show that. So I've got my project. I'll kind of bring that in. And so just like we did with the first demonstration, the cube we're using here has already been deployed and processed on the analysis server. So I kind of took care of that ahead of time. And this cube is based on the AdventureWorks sample database again, and this is the AdventureWorks sample cube, and this comes with SQL Server 2005 sample analysis services project. And in this case, our cube only has a single partition, the internet sales partition that we saw earlier, but you could certainly have a multiple partition cube. So our solution looks like it's kind of come up over here. So we'll take a look at it very quickly, and I'll bring this over so we can see it a little better. Our AdventureWorks MOLAP ROLAP cube. And you'll see I'll show you the internet sales partition. And so for this partition, proactive caching has been enabled. So it is set on a partition by partition basis. The storage mode is set to MOLAP. So we'll take a look at the details of kind of these proactive cache settings here. So you can see my internet sales. And we'll take a look at the partitions. You can see my internet sales partition. Kind of select out this row. You can see where it's proactive caching. All right, there we go. You can see where our source is, and we're doing the table binding. Just kind of waiting for things to happen here. A little slow on my laptop, apologize. You can see where you can come in and do some additional aggregation design. Take a look at my properties here. You can see where it does say proactive caching. This is kind of what I wanted to make sure you were all clear on. So if you look at the properties of the Internet Sales partition, on the storage side, you can see the proactive caching. And you can see the storage mode. Set to MOLAP. These are the critical components to kind of make this partition work. So if you need to make changes to these, you can drop down here. You can see where MOLAP is the default, but I could, in my case, I've set it that way. But you can choose ROLAP or HOLAP. And up here, you can see where the proactive caching is set to custom. If I select the Browse button here, you can see the partition storage settings window opens. And if you just take a look at this, you can see my custom setting. I'll just click in here to Options. And so you can see the storage options window comes up, and we can point to and see the kind of the enable proactive caching option here. Kind of shrink that down so you can see here, and I've enabled proactive caching. And so for this example, if you have a, in our example here, if you have a slowly kind of changing or static partition, maybe one that holds just information about a kind of a prior year's sales orders, you may not want to use proactive caching, on that partition. But since we've only got one partition in this queue and it contains all of our Internet orders, we want to use proactive caching on this partition to help make sure that Analysis Services, keeps the partition up to date with the latest information. So when you enable proactive caching for a partition, as we've done here, you can specify certain settings that will affect the MOLAP operation. So under our cache settings here, we want to update the MOLAP cache whenever the data changes. The silence interval here just specifies how long there should be no new updates on the underlying relational database. Before Analysis Services attempts to refresh the cache. So that is, we want to try and avoid updating the cache when the data is still changing in the source database. The silence override interval specifies that after a certain amount of time, even if the data in the source database is still changing, Analysis Services will refresh the MOLAP cache for the queue. And so these settings kind of let us specify how quickly we want to try to get the data when the underlying relational database is not being updated, as well as the maximum amount of time we're willing to wait to update the MOLAP cache, regardless of what's happening in the source database. So our silence interval is 30 seconds. Our override is, well, if things are still happening, let's go ahead and do an override after 10 minutes. So we want to drop the MOLAP cache whenever the data in it becomes too old. So you can specify whatever latency period you need. And I've got mine set to 0 seconds currently. And that's this configures the partition so that the moment the analysis services knows that the MOLAP partition is out of date, instead of returning stale data, the cube will automatically go to the underlying relational database to get the latest data. So once the MOLAP cache has been updated with the fresh data, we also want to bring the MOLAP cache back online immediately. So we don't have to continue to query the source database once we know that the MOLAP cache is up to date. So we've configured this partition to bring the cache back online immediately after it's updated. All right, so I don't have the update cache periodically setting enabled. All right. So to show how this works, we're going to go into SQL Server Management Studio. And run some queries against analysis services and the relational database. Let me just let this come up here. And so we're going to, we'll open an MDX query, and it'll query the analysis cube for the current total quantity of products that have been ordered over the internet. So I'm going to connect into my DC, which has a copy here, the database. So SCA DC SQL1. We're going to connect into analysis services. That's where our analysis services are running. We'll take a look at our databases. We have a database called AdventureWorks MOLAP ROLAP. And we're going to open up a kind of MDX query that we have already kind of created here to save time. There's our database. And I'll say open. And we'll open a project, let's see, a file, I guess. All we have is the query there. And grab our add new, let's see, get order quantity query. There we go. This is just going to query the analysis cube for the current total quantity of products. We'll just verify we're connecting into the right location here. There we go. And we'll choose to connect. And we'll open up the SQL Server Profiler because, before we run the query, we need to open the profiler so we can see the, activity on the relational database. And this way we can verify that the storage settings we specified for the Internet Sales partition in the cube are working as we expected. So the profiler is coming up. And And of course, we're going to start a new trace with once the profiler comes up. We'll kick off a new trace, and it's going to be our database engine we're connecting to. And we'll just specify for the server, again, the server we need to connect to. And we'll click connect. And we'll give the trace a nice friendly name, and we'll select the events we want to monitor here. So for the trace name, we'll call it maybe AW rollup. And on the event selection, we'll pick out, audit login. Let's see, we don't need audit login. We don't need to audit log out. We don't need to audit existing connection. RPC completed. All we need is the batch completed, batch starting information. So I'll go ahead and run this. Maximize that so we can see it a little better. So now that the trace is kind of running here, we're ready to go ahead and start some of these queries. And so if I go back to the SQL Server Management Studio window, we'll just go ahead and click Execute. You can see the results pane comes up, gives me the order quantity. It's querying that same, I haven't made any orders on my little test environment here on the sample database, but you can see the results should look identical to what we saw before. And so there's been no significant activity in the trace, right? And this shows that when our MDX query is run against the analysis cube, Analysis Services is returning the answer directly from the MOLAP cache because the cache is up to date. So far, we've not had to revert to ROLAP to get the information from the relational database. Does that make sense? So that's kind of why we brought the profiler up here, is just to bring home the fact that, in this case, we're not querying directly against the relational OLAP database. We're querying the cache. Since there's been no activity, that makes perfect sense. So let's do this again, but we're going to make some changes, right? Now we're going to update some information in the database and see what happens. So we're going to create some latency within the data. So for this, we'll open up a SQL query, and we'll add some orders to the relational database. We'll open up a file here. And here's our add new orders. Make sure we connect into the right database again. So we'll connect into DC SQL01. Go through and find the appropriate database. Here's my AdventureWorks data warehouse. Say connect. And now we should be ready to execute. So now in the profiler, we can see some significant activity, right, against the source database because our query has added some new orders. So the MOLAP cache for the partition was out of date, and so we're ready to see if Analysis Services will revert to ROLAP to obtain information about the internet order quantity, right? So first, let's clear out the trace data here. I go back to my SQL Server Management Studio. Well, I got to wait for everything to finish, I guess. Give it just a second. There we go. And we'll jump back here. We go back to our query. And I'll execute that. Open up the profiler. This time when the query runs, the profiler shows us that there's activity on the relational database. Right? Since the MOLAP cache was out of date, the MDX query forced analysis services to go to the relational database to get the most up-to-date information. Looks like right? Earlier, kind of we discussed the silence interval for the Internet Sales Partition. So now that Analysis Services knows that the Internet Sales Partition is out of date, it will wait through the silence interval time period and then try to refresh the MOLAP cache with the data from the relational database. So if we wait for about 30 seconds or so, we will again see trace data appear in the profiler window. Since the silence interval passed without any additional updates to the relational database, Analysis Services got the most up-to-date information from the relational database and rebuilt the MOLAP cache with it. And it looks like that was happening pretty quickly for me. I didn't move fast enough, so we actually kind of already saw that happen. So as we continue now to run the MDX query, there's no significant activity showing up in the profiler, so we know that Analysis Services answered this query from the MOLAP cache. So the MOLAP cache is up to date again, and it will provide answers to the queries until it becomes out of date again. See if we can't try this one more time here. I'm going to go back to my orders, see if we can execute the orders again. No, see, because we've already done that, so it's not going to let us redo. I wasn't sure where we stood there, so I wasn't fast enough to actually catch that. Yeah, so we're kind of stuck where we are, but it looks like we did get to see the concept of the MOLAP cache being queried. We saw how quickly it was able to update that and pull that information. Looks like I took close to 30 seconds to make my changes happen. So let's jump back out of here. But you get the idea. And this certainly, you can test this out on your servers, right? You have all the tools in place to do that. I showed you how to set up the proactive cache, how to point to the MOLAP cube cache, I should say, and how to configure this. You can go test this out. Create your select statements, create your add orders, and see how the behavior of the querying process works. So the question of efficiency comes up now, right? How do we avoid analysis services with frequent updates, and how fast can the cache catch up? We saw pretty fast in my scenario. The primary issue here with performance and regarding proactive caching is finding the balance between latency and performance. So these are conflicting ideas, and we have to decide how to balance them against each other in our environment. So change notification is another challenge. We need to decide whether the cache will be refreshed when data changes in the source database or on some time interval, regardless of whether or not the source data has changed. If we decide that the cache should be updated when the data changes, how will analysis services know that something has changed? And there are several policy settings that we can define that will control how analysis services will rebuild the cache. So these can be set on each partition and each dimension, I should point out. I didn't mention that earlier. Individually, either way, right? So the silence interval determines how long there must be a quiet time with no updates before a rebuild of the cache starts. The default setting, by the way, no quiet time. It'll start rebuilding the cache right away. But if you have a silence interval defined and the source database is being updated all the time, we need to specify that silence override interval. And this instructs, analysis services to begin to cache rebuilds after a certain period of time has passed, even though there's no full silence interval, right? So any further notifications will not cancel the rebuild once it's begun. So make sure you're aware that a rebuild starts and it's going to finish. There is the force rebuild interval, and it allows us to tell analysis services to rebuild the cube, say, every 30 minutes, for example, regardless of any updates to the source database. So even if it doesn't see any changes occurring, you can still go and do that rebuild, force it to happen. So once the rebuild is started, update notifications will not cancel the rebuild. So how do we handle large quantities of data? When there's a large amount of data, recreating the cache whenever data changes is expensive, prohibitively so, right? So we need to be able to keep up to date without overloading either analysis services or our OLTP source database. So there are several things we can do to help make this happen and help still give us good performance, relatively low latency, and still provide real-time BI. So first off, we need to use ROLAP effectively, and we saw this earlier. We can also use partition. So as an example there, we may have a partition that contains historical data from the MOLAP cache and another partition that contains the most up-to-date data from, say, the ROLAP sources. We can also use incremental cache updates to update the cache. So if analysis services receives periodic notifications about updates to the source database, we can also use a query to determine which rows in the MOLAP cache should be updated based on those changes. So using these solutions together can really help us to effectively provide real-time BI while ensuring the availability of all of our LTP database. Right, so that force rebuild interval, -1 is infinite, and that means there's no periodic rebuild. But 30 minutes or an hour or a day, 24 hours, whatever you want, might make some sense. That latency, how out of date can the cache be before reverting back to ROLAP? Just to reiterate, again, a -1 is infinite, so never revert to the ROLAP mode if that's what you want. You have those options. So is it going to use the relational OLAP database, or is it going to use, or is it not, right? And so -1 is infinite. Otherwise, any other setting above 0 or above will allow us to revert. So when scaling up, how do you handle large quantities of data? Well, recreating the whole cache is, as I mentioned, too expensive. And the solution here really is to use ROLAP. Use partitions or use incremental cache or a combination of these things to help address that large, data scenario. So use incremental cache, updates to add data. And so this becomes another solution that makes sense for you. Let's do another quick demonstration and we'll close out here. So we're going to show now another way of providing real-time business intelligence, and this is called automatic MOLAP. So automatic MOLAP uses polling queries to update the analysis cube. So with polling queries, we periodically issue queries from analysis services to the underlying source to see if changes have been made. So if changes have been made to the source database, analysis services then issues a processing query to perform an incremental refresh of the cache, and this will update the relevant rows in the queue. Let's kind kind of close everything down here and start from scratch. So we're going to open up a new solution, our solution that we have here. And we're going to jump in. And this will be our InventureWorks automatic MOLAP. We'll open up this solution. And once this comes up, we'll take a quick look at this cube. And this is just another InventureWorks cube, just like before. You know, this one's already been processed and built. And we'll just take a look at the partition settings first for this cube. And as with the cube we used in the last demonstration, we've got proactive caching enabled. There we go. All right, so if you select that out, you can again verify proactive caching is turned on. The storage mode is MOLAP. Again, there's a lot of additional settings you can configure here. And you look at your custom settings. This is automatic MOLAP. Go to the options. And so here we've specified, you know, that the silence interval and the silence override interval are 0 seconds. What does that mean? You should probably realize by now what that means. But I want to tell you again so everybody's clear, right? Because it's hard to kind of follow along sometimes if a lot of these concepts are new. So in this case, the 0 seconds for the silence interval and the silence override interval means that the cache will update immediately upon any change to the data. And this will ignore activity on the underlying relational database. So the second a change happens, the cache will update. Right? So we do not automatically drop the cache when it's outdated, however, like we did last time. So I have not selected off to drop the outdated cache here. If you look at notifications, we configure our polling queries here. And so with the scheduled polling, we pull the source database once, every 10 seconds for this particular partition. Because it contains sales order data, where we would expect to have a large number of new rows added to the relational database in a short amount of time, and we want to use that information in analysis services as quickly as possible. So if you're using polling queries to check for updates to data that changes less frequently, maybe a table, I don't know, that contains a list of a component part numbers, right? So part numbers. You may choose to poll the relational database less frequently. But this is sales data. So by enabling incremental updates to the cache, we make sure that we're not reloading the entire cache when the data is updated. This helps ease the load on that relational database and also improves the performance of the MOLAP cache. So you have enabled proactive caching. And I've enabled incremental updates. So look at the polling query field here. This is run by analysis services at whatever interval you specify. Remember, for us, it's every 10 seconds. And so if I open this, click on the ellipse here, I can get more information about the polling query. And so in the bottom pane, you can see the SQL query that occurs. Select max sales order line number as expression 1. You can see if the polling query returns the same value as the previous polling query, no action is performed. And analysis services considers the MOLAP cache as up to date, even if the data has changed elsewhere in the relational database. Does that make sense? So we're conducting this query. If we get the same result back, we'll assume nothing's changed, even if it has changed somewhere else in another part of the relational database. So, for example, if we've added a new product to the relational database, but the total order quantity has not changed, analysis services would not run the processing query to update the MOAB cache. So the MOAB cache would stay as it was, no update. Cancel out of that. I just want to show you that polling query. That can be changed, modified by you to identify what it is that you want to poll to see if there's been any changes. In other words, what is it you want to look at to determine if the MOAB cache should be updated. You're going to look at orders, you're going to look at the order quantity, you're going to look at order numbers, whatever. So let's just cancel out of this. Cancel, minimize that. And we'll take a look at the report. So on my desktop here, I've got the report manager already opened up. And so we have essentially two reporting service reports that we've created. The first report essentially runs against the analysis services cube, and it gets its results from the MOAB cache. The second report we have here runs directly from the relational database. So both of these reports are just designed to return the total number of products ordered over the internet. And so we're going to look at one from the cache and one directly from the relational database. See my two reports that I've added here, just for simplicity's sake, to kind of bring and drive everything home so everybody knows what we're doing. See if I can get this to speed up. I'll click directly into the MOAB cache report. It can take a minute or so for this report to load, especially when it's the first time I've actually spun up this web server, so it takes a second for it to come up. While I'm waiting, I'm going to do everything I can to expedite. I'm going to create another window, another IE window, when in fact everything I'm doing to expedite probably just slows things down, but that's all right. Usually you want to wait for one thing to finish before you start another, but we don't have a lot of patience in the IT world. At least I don't. So my MOAB report is coming up. The second window I'm going to use to just have a comparison there, the one that queries directly against the relational database. There's my MOAB report. New window. This one will be relational. Much faster now, right? So both read 60,477. I think you can see where we're headed with this. And let's go ahead and make sure we can kind of see both of these at once. There we go. That's good enough, right? All right. So let's go back to Visual Studio here. Remember, this is a Visual Studio that ships with SQL Server 2005. And I'll scroll up to my Add New Orders Integration Services package. And all this does is this real simple IS package. It just adds a few orders to the table in the relational database, right? The sales table. And so once this package executes, I'll go ahead and start debugging here. Orders have been added directly to the relational database, but they won't appear in analysis services until the polling query runs. So our polling interval is 10 seconds, so we won't have to wait long until analysis services processes. You can see the package execution has completed. If I go to my relational report and do an F5, it just finished, 60,502. And I'll refresh here. So you can see that we have a number of new products that have been added and ordered. And since the total order quantity of the relational database has increased, and so when we refresh the report that is derived from the information in the analysis services cube, we see that the cube is already updated and refreshed the cache. So analysis services use the polling query to detect the relevant information in the underlying source database. Remember that polling query I showed? It showed a change, and instantly the MOAB cache updated. So in the first presentation, the last demonstration, we saw a delay because we had put a delay in with the silence interval. In this demonstration, we saw there was no delay, very quick. So we saw 60,502 immediately in both locations, or as close to immediate as we can get. So this demonstrates another way, that we can effectively provide real-time BI to our company using analysis services. Really kind of brings together everything, and I think, yep, we are good to go. So first, we saw that real-time BI is possible in SQL Server 2005, at least within a few minutes, right? Which is a heck of a lot better than we ever had before. So using SQL Server 2005 components like analysis services and integration services and the OLTP database, we can get that up-to-date business intelligence throughout the company. So there may be challenges around it that we talked about at the beginning, but those challenges can be addressed in many different ways depending upon what our needs are. So there are many new technologies in SQL that really provide this real-time BI or help us to provide that. Just to refresh our memories, last time, drive home all the points. What are some of the things? The ability to load data directly into an analysis services cube from integration services without an intermediate database. Snapshot isolation, another way that we help to provide real-time BI. Proactive caching, another way we help to provide real-time BI. So maybe I sound like I'm preaching here, but I'm just trying to say there are a lot of things we've done to help us out, and that's a good thing, right? We want to have that help to make this stuff work. So when you use these things together, they really help to allow us to create several different types of architectures or applications to provide that real-time BI from a number of different sources. So wherever they might be in our enterprise, so DB2, Oracle, whatever, we get that kind of true view of that data. One true view. So we've seen several examples of how you can apply these technologies, and we've seen them update in different ways. So there's some online resources that can give you some more help. I would strongly recommend you check out, Microsoft.com/TechNet. Do searches on real-time BI, SQL Server 2005, anything, analysis services, proactive caching, integration services. Should all give you some information. You can also go to this link, Microsoft.com/TechNet/SQL-09. Another thing you can do is come to live events, right? We're not doing any SQL events right now, but you can certainly ask your presenter about them. He or she will probably know something that will help to move you along that path. And so you can sign up for live events outside of online. If you have a chance to go to an event, right? You go to technetevents.com. You can sign up for free live events put on by Microsoft employees. So www.technetevents.com. I really want to thank you for coming. I'm going to hang out. I see there's a few questions in the queue, but please don't leave yet because I know Heather has something important to tell you. Heather?
All right. Thank you so much, Sean. And if you do have any questions for Sean, please go ahead and submit those now using the questions and answers pane in the lower right-hand corner of your interface. And we will get to those questions in just a minute. I'd also like to remind everyone that you can print a PDF of the slides by going up to the File menu and selecting the Print to PDF option. When you fill out the webcast evaluation today, you have a chance to win a Microsoft Zune 30 gigabit digital media player. And I will go ahead and launch that survey now. You should be seeing it showing up in your slide area. All you need to do to fill it out is click on those links right there in the middle of the page, and it should just take you a few moments. We do appreciate your feedback and also your comments if you have any ideas for future sessions. All of that helps us to improve our webcast for you. And at this point, I'll go ahead and turn it back over to Sean to wrap up with the questions.
Thank you, Heather. I know Heather already talked about it, but I want to remind you again. There's no way we can tell if we're doing a good job on these events if you don't fill out the survey. So please fill it out. Let me know. Remember, a 9 is good, a 1 is bad. My boss thinks anything under a 7 is failing, and he'll want to know why. What did you do wrong? So So kind of give me some comments in there if you can, and let me know, if I failed in your mind or if I'm not performing, delighting you. Please let me know that. And again, chance to win a Zune. You can't beat that. So click on that link. That link is active there in your live meeting window. They're registered online, or all other registrants. Okay. Thank you, Heather. I just wanted to I'd like to remind everybody how important those are to me. Okay, so let's jump to the questions. I see a couple here, and I'll take. Well, so we see three, so we'll try to take all three. Patrick asked, in the multiple source scenario, can you explain again why one of the underlying sources must be SQL Server? And I appreciate the question, Patrick. I probably didn't explain it all that well. It's actually pretty simple. One of the sources needs to be SQL because we are using the distributed query processing capabilities of SQL. All right? So, even though SQL has to be one of the sources, we don't actually have to pull any data from the SQL Server. It just has to be a source because we're going to use, the distributed query processing capabilities of that server to get things done. So, again, the example I think I mentioned was we could be loading data directly into UDM, where the source data all comes from Oracle and DB2. And we're just using SQL Server to do the distributed query and the join in that scenario, right? So it's got to do the query and the join. We need SQL just in place to do that. I hope that helps answer your question. Thank you. Dan Egan, where is a good online source to learn more about MDX and writing MDX queries? Ooh, good online source for that. Well, I don't know. I've always found MSDN website to be one of the best ones. And I usually, when I do searches on Microsoft, I try to go directly to the site. So if I do, msdn.microsoft.com, and let me just see if I can't find something here for you real quick. I don't have anything off the top of my head, but if you just go to msdn.microsoft.com/SQL, SQL, this is where I would conduct my search from, and let me just see if I have a quick link I can help provide. I know there's most of my information I just got from one white paper out there, and I don't think it was directly on MDX. Here's an overview that you might find helpful. Let me provide this link to everybody in the question manager. It's pretty simple, but there are some jumping off links that you can take from here that might push you in the right direction. But I'll kind of post this to everybody. And if you want to copy that out of the question and answer pane, you have to highlight it, with your mouse and then do a Control-C because right-click is not enabled in that window. So just to point that out, use a Control-C and then Control-V it into your browser. Dan Egan says, thank you. Okay, appreciate it, Dan. Thanks for coming. It means a lot that you guys show up and spend time with us here. And I hope you got a lot out of the session and the demos. But looks like Deepak has another question, or a question, I should say. He says he set up proactive caching with polling queries to update dimensions and then queue partitions. Well, that's great. The polling query should just be a query, but let me see if I understand. Dimensions update reliably, but partitions often do not. Any advice to troubleshoot this? Ooh, boy, that's kind of a special situation. Naturally, I would start out by doing traces to find out exactly what's going on, and really try to do some debugging, figure out why it's not happening. So I'd pull it out of the polling queries and see if I could just do it manually. If it works manually, okay, but just doesn't work as a query, you might try. I'll tell you what. Why don't we take this offline? You have my email. It's seant@microsoft.com. And we'll see if we can't come up with a good answer for you. Well, listen, I don't see any other questions. Deepak, I'll touch base with you afterwards. But listen, thanks everybody for coming. It means a lot to me. Please fill out your survey. And remember, I love you. Microsoft loves you. We'll see you at the next webcast. Thanks again.
All right. Thank you, Sean, for your presentation today. And thank you all for joining us. This concludes today's webcast. You may now disconnect from the audio portion of today's conference.